Good morning, everyone. We're delighted to be here with you this morning. We have this morning a panel on fittingly following Dr. Magnus's talk on the research challenges with mission engineering. Dan DeLaurentis from Purdue and myself will be the moderators of the panel. If you go to the next slide, Kara, please. I think as you heard from Dr. Magnus, there's an increasing interest in defense in particular on applying systems engineering and digital engineering, in fact, to missions, looking beyond individual systems and really moving to deal with the complexity of operations and systems and various new technologies. The panel that we have today are going to take a look at mission engineering from a research perspective. And the purpose of the panel is to look at mission engineering from a variety of perspectives and really address the research challenges posed by applying systems engineering to missions. Go to the next slide, Kara, please. I think just briefly to kind of lay out the context, though following Dr. Magnus was really a very good setup for the panel. I have on here the definition DoD has set for mission engineering. Really the deliberate planning, analyzing, organizing, and integrating of capabilities, operational and system technical capabilities, brought together to achieve desired operational mission effects. Now, in effect, mission engineering is really looking at missions, end-to-end defense missions, treating those as the systems, as a system as a whole. Recognizes that individual systems, while we apply systems engineering there most predominantly, are really components of these larger missions and systems. And applying systems engineering up at this system of systems level with an operational mission outcome is become increasingly a thrust in the department. It goes beyond data exchange to really look at the type of cross-cutting capabilities critical to executing military missions, looks at trade-offs across missions and operations, and provides a vehicle to apply engineering to effectively compose mission capabilities in much more of a dynamic fashion to deal with today's military challenges. So next slide, please. Given that context, we have a panel of folks from a variety of perspectives to really address the issues. We've asked each one of the panelists to kind of address three areas. First, to introduce themselves and sort of give us some insights on how they're related to this mission engineering set of activities. From their perspective, second, to identify what they see as being the major challenges that we face as we move systems engineering into this larger complex area. And then finally, to offer their thoughts and perspectives on the kinds of themes and directions that they believe we as a community need to move in order to provide capability for mission engineering. The panelists are listed here. Elmer Roman is in Dr. Magnus's organization, is the director of mission integration. So this is an area that basically keeps him up at night. Alejandro Salado from Georgia Tech, Dorothy McKinney, Ryan Noguchi, and Donna Rhodes will each be then providing their perspectives on mission engineering from their viewpoints. So next slide, please. So with this, Elmer, I'll turn the podium over to you. Oh, just before we start, I want to mention what Dan will moderate the questions and answers following all 5 of the panel presentations. And if you could use the question and answer tab to put your questions in as the presentations proceed. And Dan will then use those questions when he moderates the question and answer period. Okay, Elmer, now over to you.
All right, thank you, Judith. And if you can go to the next slide, I would just say from my perspective, like Judith mentioned, I'm the Director of Mission Integration at the Office of the Secretary of Defense for Research and Engineering. Within that, there's the Office of Advanced Capabilities that is led by Mr. Jim Feist, and then under engineering, Dr. Magnus, there's this mission integration. Why it's important to mention mission integration? If we look back at the 2017 NDAA, really directed the department to conduct mission integration management as a way to coordinate and synchronize the investments that we make in the department, especially as we look at new warfighting concepts and focusing them on the mission, and then from there on be able to derive what sort of investments we need to do, we need to make in technology. Really, is to provide an operational context for the investments or the technologies that we develop. So within the R&E, the lines of efforts that we have adopted include not only just the studies, and in this case what we call mission engineering studies, but then at the same time as well is the development of government reference architectures that are derived from missions, the mission analysis. That one is articulate what the mission is, or the mission threads, what are the variables from a mission engineering perspective that basically identify a problem or an objective for a commander's intent, and then on what are the options, capability options that we can do to perform that mission. So from there, that's where we derive our mission reference architecture or the capability reference architecture. And then we use this architecture to then further the analysis to one is articulate perhaps new warfighting concepts, and that we work with the joint staff, the combatant commanders, the services to basically articulate new ways and different ways to really accomplish a mission objective. But then it's not at the same time answer the key questions, such as are we building the right things? I mean, it's not only building things right, which is what the focus has been with regard to systems engineering. I'm a system engineer myself, and I've done basically mission engineering throughout my career, both in the military and as a civilian. But then when you start developing modernization plans within the department, how do we looking at it from an operational perspective, and then bridge the gap between the technology side or the technologies and the mission planners and the operational and the warfighter. So that's what's critical about mission integration, mission engineering, and then of course mission engineering is that technical component or instantiation for mission integration. So you have studies, you have architectures, and then we have this component of had to do with processes and tools, modeling and simulation, that ecosystem, digital ecosystem that we need to be able to bring the community together and converge towards a common set of models and standards that we use for these activities. If you go to the next slide, basically that articulates our views of some of the challenges that we have. In addition, as just mentioned, it's this critical challenge we have of bridging the technologies or the technology side with the operational planning on the warfighting side, which is kind of the key component of mission engineering. It's really the challenge of, okay, how do we analyze and use mission engineering into some sort of a repeatable process that allows us to analyze systems across all the domains with the tools that we have today. I mean, the challenge we have is in many cases, the missions that we're analyzing for our joint warfighting concepts are perhaps long term, it's a 2030 time frame, and being able to project the capabilities that our competitors or adversaries will have versus the ones that we have and will have, it becomes a challenge. Also, evaluating the interrelationships and the flow of information between all the systems in a complex operational environment, and then be able to develop those architectures that are usable and relevant to the community, so that we can perform that trade analysis becomes critical. You also have the challenge of make sure that we have a repeatable process that everybody buys into. We're in the process of releasing a mission engineering guide to help with that process, make sure that we kind of speak the same language. Right now, mission engineering is really being done by industry, by the department, by the labs. However, we kind of speak a little bit of a different language. I hope that with that mission engineering guide, eventually we all kind of start converging towards one common language that we can all understand each other. But in a sense, the mission engineering guide also is going to be a living document that we expect to also adopt concepts from other mission engineering practitioners, and if able at the end make it a living document that we all can continue working on and basically enforcing the mission engineering community. Then we also have the department. How do we then bring and put all this together into a knowledge management or knowledge repository that you can have access to? We can have access to the data, curated data, the models, the reports, the architectures, all that analysis that has been done that is critical for people to have access to, and then of course so that they can do their studies and their analysis. And then finally, it's make sure that we also connected with those that are working on understanding the threat as they're projecting it out in the future, and as well as perhaps some sort of a top-down approach to improve mission outcomes, so that results coming out of the mission engineering side of the house is leveraged by those that are making investments or decisions that are more of perhaps on the financial side of the house. That might be the CAPE, might be the decision-making makers at the SecDef level. Could be our acquisition and sustainment folks, PEOs, the program office, and so on. So those are a challenge that we need to work on, but that's of course part of the process as we instantiate mission engineering in FY21. And I think my next slide is in terms of mission engineering and what it brings with our architectures. I think the bottom line is to start with a mission and the mission outcome in mind. I mean, start with that. Right now, well, the way that the department designs or implement or takes the capability from concept to capability and deployment is basically think about the platform first versus the mission. We want to be able to reverse that by the analysis and the composition of this mission, be able to characterize those mission threats and understanding the different options that we have. Perhaps instead of a missile, it could be a directed energy weapon, or instead of a directed energy weapon, could be an EW capability. Understanding that mission, that architecture, understanding what are the mission objectives and the measure of success, either being a measure of effectiveness that allows to the commander to be able to accomplish what's good enough to be able to get the mission done, and then backtrack to what's the right platform that we need to conduct the mission. Again, the way we do it today, we have multiple platforms and we try to find the mission for the platforms. It should be the other way around. We should have a mission, that a mission identify what kind of platforms do we need to accomplish the mission. And then the last slide, it talks about then that knowledge management ecosystem that we want to be able to create. And that, I think, is critical because it allows us to be able to have that one repository that gives access to the community. We should go to the next slide, please. To the community, which provides a transparency of the programs and the data that we use. I mean, I think it's really critical that when we go in and talk and sit down in the Pentagon and we have meetings and discussions about where investments should be made, we should be talking from the same common ground, same perspective. And that's where the performance data on these different systems and models that we have is critical. As well as we should be able to leverage what industry is doing. I mean, there's a lot of, and then as well the warfare centers, but there's a lot of tremendous amount of data and a tremendous amount of good models that are out there that is being used in some sort of a stovepipe approach. We really need to be able to have access to that and integrate and don't go out and reinvent the wheel. So I think it's critical part of our process for our mission engineering activities. So it has to be a collaborative environment that's tailorable and usable for the community at large. And then, of course, and the same thing goes with the FFRDCs, academia, and others, all the models that are out there, the UARCs that we should be able to tap into. And then allow us to increase that interdependencies, so that as we do perhaps program oversight, some oversight is well informed, and there's actually add this analytical rigor, engineering rigor to that analysis. For the most part, a lot of this analysis being done today is more from a qualitative perspective. We want to be able when we actually make the final decisions, that we have also a quantitative way to determine what's a performance measure of performance for a particular platform or need a platform, or whether we have a platform that we think might be able to accomplish the objective. Well, be able to measure that with some really some real high-end modeling activity that allows to be able to determine whether the capability is useful or not. And then finally, it's again that collaborative environment that allows to as well curate the data for analysis, and then of course, depending on the complexity of the problem, be able to determine what's the right mix of models and data and tools and timeframes that we need. So I think it's, and again, in a nutshell, mission engineering adds that engineering rigor to our process. Also allows to be able to communicate across the board with the systems engineers that are eventually going to be doing the system level design and architecting. But mission engineering is that thing's left of system engineering, and then hopefully we give a proper handoff of the capabilities or the information that they need, so that they can then do their decomposition analysis or functional analysis for their requirements and so on. So that's in a nutshell my talk, and I'm open to questions when the time allows.
Excellent, Elmer. Thank you very much. Next, I'll turn the podium over to Alejandro.
Thank you, Judith. Good morning, everyone. For those of you who do not know me, I am an assistant professor of systems engineering with Virginia Tech. I do consulting on systems engineering and enterprise transformation, and then before coming into the academic world, I used to work in the space industry as a systems engineer. So for my 10-minute talk on the challenges and that I see for mission engineering, I will frame them within, I guess, my own highlights of the exposures that I have had with systems engineering. So probably the first one is before I came to Virginia Tech, I was the chief architect for a space weather mission for the European Space Agency. And this was a large endeavor in which we adopted a system of systems engineering approach. And, we had distributed governance, over 400 ground-based, space-based systems, assets that we had to trade between, and that gave a practitioner's perspective to what challenges we faced as we tried to solve that problem, as compared to just working on a single satellite or a single space mission. Then lately, I had the pleasure to serve as the co-editor for the ISO standard that explained how to apply 15288 in the context of systems engineering. And again, that provided nice insights as to what are the expectations of working with system of systems on mission context, as opposed to the traditional systems we are familiar with. Right now, I'm serving as a research and consultant for the Army, and we're working on architectural assessment and program formulation for CAS and MOSA, particularly on how to measure quality attributes across different platforms to satisfy the mission needs of the Army. And then finally, I'm serving as the director of future graduate certificate in mission engineering at Virginia Tech, working on the specific learning concepts and learning outcomes that the students will have to get if they want to work in the field of mission engineering. So, Kara, if you could please go to the next slide. So I'm going to frame the main challenges that I've seen in three chunks. So the first one is really from the ISO standard. And again, our task was to apply 15288 to SOS, or at least to define in this standard how you want to use 15288 in the context of system of systems. Now, 15288 lists around 180 outcomes of applying systems engineering. And the approach we took for creating this system of systems engineering standard was to go outcome by outcome and redefining what is expected out of this outcome in the context of system of systems. And we could only use 50 of the 180 as stated. Okay, so only on 50 we said this outcome applies as stated. For the rest, around 130, most of them read something along the lines, depending on the managerial and governance independence of the constituent systems, blah, 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 blah. And I think this was really interesting for us to frame the real challenges of system of systems. Number one, the granularity, the sensitivity, the specifics of each mission was astounding, okay? We didn't have ways to really categorize system of systems as one type of element different from traditional systems. There was so much variety that it was extremely difficult to explain what a directive could be. As a matter of fact, we could not really provide any directive. It was more guidance, right? Most of the statements were, well, if you have, governance independence, you might have to do this. Or if you have managerial independence, you might find yourself in this situation. It does not mean that you will, it's only that you might, and this approach might work, it might not, okay? And that's pretty different from the 15288, the way it's written for traditional systems, which are much more predictable. The contextual information, the contextual variables that characterize them are much more common and homogeneous. Now, the second challenge of that statement was that well, I will go to there. So the second problem with the statement of dependent on managerial and governance independence was that we do not even know how to do that yet. Okay, there was a lot of blurry stuff, a lot of fuzziness on. Yes, we have a sense. We do not really know how to measure those things. We do not really know how to control to some extent the outcomes. And I think Elmer was talking a little bit about that on the qualitative nature with which we address mission engineering. Kara, could you please go to the next one? Now, in our working problem formulation now with the Army, it's interesting that we are realizing that as we work on quality attributes for mission level across platforms, that we find a more and more emphasis on outcome than actions of or outputs, on achieving a state other than receiving an output from the system. And this is also, we find that to be extremely different from traditional systems. The notion of functional analysis becomes again more blurry, because in functional analysis, you understand what the outputs are, but here with missions, we really want to understand what the outcome is. And once again, we are finding that we do not have many methods that are outcome-driven or outcome-based. Actually, if you take most systems engineering books, they may talk a little bit about outcomes when defining stakeholder needs, but it's extremely limited. It's just they fly over it. And however, for mission engineering, we believe that it really becomes central, and we lack methods to do that. In terms of achieving that outcome, we find that in missions where you have, again, independence managerial, potential independence governance, we cannot exercise control, and we cannot even control the balancing of conflicting objectives that definitely appear. But we have now this self-balancing of the objectives. We have kind of an influence and persuasion, a preparation for maybe achieving certain outcomes in the presence of conflicting objectives as the system is deployed. And again, that methods that are not based on control are not extremely common in systems engineering, and that's something that I believe that we need for mission engineering. Can you go to the next one? And then in terms of architecting, and this is from the Space Mission Project, the two main issues that we found there were, first of all, size and heterogeneity, okay? The size of the problem was way, way larger, several orders of magnitude larger than what we were used to do. And that implied that we did not have quantitative methods to make trade-offs. It just, algorithms would not converge. It was basically impossible. There was a lot of art, a lot of shortcutting, a lot of qualitative guessing and assessments in that. There was also a new aspect for us, which was the amount of endogenous causes for the mission not achieving its objectives were way, way higher. In traditional systems, you have either exogenous factors that influence change, right? You have inputs that you did not expect, budget cuts, you've got changes in requirements and things like that. And the only endogenous factor was really reliability, right? Either the system fails or it doesn't fail, and that's the only thing you had to control for. Now, when we were architecting for a mission and we had the systems engineering approach, and once again, going into managerial and governance independence, we realized that the amount of endogenous factors that might make the mission fail were crazily high. Now you have systems that may live without a further notice. You may have independent fluctuations on elements on the system that you couldn't control. You have self-evolutions because of their own independent reasons that you couldn't control, and suddenly the system is no longer, a constituent system is no longer compatible with the whole mission. And once again, we couldn't predict effectiveness because we did not have the tools to account for those endogenous factors that did not exist in traditional systems. And now I will finish with the next slide, Kara, if you may, please. So how do we move from here? Well, I take down my researcher hat, And I believe that it is time to bridge the gap between systems theory and systems engineering. I know that INCOSE has an initiative for establishing foundations of systems engineering. The NSF has also initiatives for establishing the theory of systems engineering. And I believe it's time for us to start to leverage those, close the gap, because there is a lot of vagueness. If you look at papers out there using the term mission engineering or using the term system of systems, you say that it is a disparity that is not manageable from the application of science standpoint. It is everything, there is a blur between actual needs, actual definitions, buzzwords, interpretation. And if we really want to bring quantitative stuff into mission engineering, I believe it's time for us to have a stronger focus on systems engineering and systems theories, and also try to come up with the theory of systems engineering for closed systems in which the outcome is what matters, not so much the outputs and the actions and the functions that systems implement. And with that, I'm finished with my intro, actually. Thank you.
Great, Alejandro. Thank you very much. Everyone, please remember to put any questions that you have up into the questions and answer block so that we can have these queued up for the question and answer period. So at this point, hand the podium over to Dorothy McKinney.
Hello. So if you can bring up my first chart. So I'm currently a systems engineering consultant. I'm working on a project with Northrop Grumman for the next generation of surveillance satellites to look for rocket launches and explosions and whatnot worldwide. I spent close to 40 years at Lockheed Martin and retired from there as a fellow emeritus. So the first comment I'd like to make about mission engineering is that it's actually recognizing challenges that we've faced in recent years as system of systems have become more complex. The number and variety of stakeholders' perspectives has expanded. Resources have become increasingly limited and constraints have multiplied. And systems engineering has increasingly been held responsible for unintended consequences, including all of the outcomes of deployment and operation of systems. And for many of us, we've been trying to do mission engineering for decades. I can give you one small example. A couple of decades ago, I worked on an air traffic control system, and the contract was with the Federal Aviation Administration of the United States. And there were contractual and legal restrictions that kept us from talking to any of the users who were air traffic controllers. And we thought the chance of successfully developing a system that would be deployed and used and serve the intended purpose without the involvement of users was very, very low. So we decided to do an end run around the constraints. We set up a demonstration lab and we put out an informal word across the United States to air traffic controllers that if any of them happened to be in the Maryland, Washington, DC area on their own time, they were welcome to come into our demonstration lab and give us their feedback. And as eloquent evidence of how much other people cared about mission engineering, not just contractual functions, we had literally people from across the country. There was one gentleman who paid his own airfare to come from Washington State to Maryland. That's a 3,000-mile flight. And he spent a whole week with us looking at what our prototypes were and giving us feedback. We actually ended up with a system that was usable by the end users. So my first comment is many of us have been trying to do this for decades, and it's really encouraging that there is now formal recognition of the need for mission engineering as opposed to just system development. The other observation I have is that mission engineering poses a lot of difficulties for engineers. The skills needed are far beyond those that traditional engineering skills that we teach in most engineering curricula. The number and diversity of backgrounds and the education or lack thereof of the different people that we have to interact with poses many difficulties. It's much easier to engineer in a bubble in which you are given requirements or user needs, and you develop a system. But all the interaction with all the other stakeholders is a very messy business and requires a lot of human interaction that most engineers aren't trained to do. And although some customers are now asking us to do mission engineering, it's not clear that they're willing to provide the additional resources that are needed. So those are real challenges. Next slide, please. So there are two key challenges that I'd like to share that I've observed. One is worse than the problem of learning new things, is we actually have to unlearn some conventional wisdom and existing knowledge. And we need to not only do this unlearning ourselves as systems engineers, but we have to help customers and other stakeholders do some unlearning too. And it is really, really difficult to do that while you're doing paid work for the dog you're trying to teach new tricks. It's not easy at all. The other key challenge I'd like to highlight is that we're not used to doing interactive novel option generation. That is, combining psychology, systems thinking, decision science, and expertise from not only different disciplines, but also from those stakeholders who don't have engineering training or systems perspectives, but do have critical knowledge that's needed if the mission engineering is going to succeed. So that is really tough to do. It's a difficult challenge. I'll just share a couple of lessons that I've learned in trying to do mission engineering that I find interesting. One is that quirky or non-traditional personalities seem to have an easier time of convincing stakeholders to cooperate. So the systems engineer that is better at getting a crowd laughing might actually be more effective than the best system architect we have in the house. And it's a challenge to get the engineering teams on board with allowing informal leadership from the folks that are good at involving people and getting them to share ideas in different ways. And the second thing that I found very interesting is that iteration used as a learning tool seems to be much more important in mission engineering. The build a little, test a little philosophy that some of us used 40 or 50 years ago has sort of morphed into we need to jointly experience things in order to get everybody on the same page, and or actually you don't get them on the same page, and in order to get some subset of the people on the same page and to get everybody sort of moving in the same general direction. And how to do that iteration in a cost-effective and time-effective way is something that many of us are still learning about. And I think that may have been my last slide. Is there another one? Oh, okay, yes. So how do we address these challenges? Transdisciplinary systems engineering offers several approaches that I think are really useful in mission engineering. The disruptive collaboration, and the first time I ran across disruptive collaboration, I thought it was an oxymoron, but the more I read about it and thought of it, the more I realized that it's a way of getting us out of the traditional approach and getting us into collaborating in a way that works better for mission engineering. And then rather than the old interdisciplinary approach, the transdisciplinary fusion approach, where we're seeking to identify new knowledge that's needed and co-create it, is I think really powerful. The use of things like augmented reality. I mentioned iterating to learn. Well, one of the cost-effective ways to learn together is use augmented reality, because you don't have to take the time and effort to actually implement the full thing. You can just fake it, if you will, as the movies do. And I've already mentioned co-creation of knowledge and unlearning. So some of the enabling technologies that can help us get there include convergence of engineering and entertainment, so that engineer who as a teenager made movies in his or her spare time is actually a solid goal for your team to do this. Using model-based methods with interactive storytelling. So most of us, when we started modeling, at least I know when I started modeling 40, 50 years ago, my aim was just to generate data and then information. But modeling can be very powerful as a way of experiencing a story. The use of things like crowdsourcing and social media, again, those are not skills that most of us engineers learned, at least not in our formal engineering curriculum, but again, it can be very powerful in involving stakeholders. The idea of enhancing empathy, again, is not something most of us engineers were trained to do. So bottom line, I'd say in order to be effective mission engineers, we have to develop a new skill, which I sort of have this vision. If you think of the World Wide Web and the social web of people around the world as sort of like a net, you can bounce across the net, picking up and weaving threads of new meaning as you go. And with that, I will end my introduction. Back to you.
Dorothy, thank you. Very interesting perspective. We'll now turn to Ryan. Over to you.
Thanks, Judith. So, Karen, next slide, please. So I'm Ryan Noguchi, the Director of Space Architecture Department at the Aerospace Corporation. Have been involved in all these activities you see at the bottom here, and I think really they each of these bring substantial insights and capabilities that can really enable a practice of mission engineering as we practice it. So system architecting, we really focus on trying to understand the increasingly complex problem space and the breadth of the solution space before trying to dive into formulating a singular solution concept. And our architecture design and evaluation process that we created and use at Aerospace is very closely aligned with the mission engineering process that Dr. Magnus showed us this morning. In enterprise architecting, we try to understand holistically the many stakeholder needs within the enterprise and the context within the enterprise and the people within that enterprise operate and evolve. And that's very key in bringing together those organizations that need to contribute to achieving the mission. In systems engineering, particularly for collaborative systems of systems, we focus on the interfaces, interactions, and incentives that are needed to achieve the integration of systems to achieve new missions. For enterprise systems engineering, we apply our SE methods and principles to the enterprise itself, where the people and processes are within the system boundary. And with MBSE and digital engineering, we've been trying to capture the breadth of knowledge that spans multiple disciplines, life cycle phases, and organizations, and connect those many local pockets of knowledge into a global body of knowledge to inform the overall enterprise and mission engineering process. So if you go to the next slide, please. So this is a very dense slide. I'm going to spend most of my time here to talk about the various technical challenges that I've characterized on the left and the non-technical challenges on the right that are facing mission engineering. So mission engineering really requires us to integrate knowledge that spans a very diverse set of enterprises and the full mission thread. And that means we really need to rely on the many members of our organizational family and our partner agencies to provide their locally held knowledge to contribute to our understanding of the landscape of available assets. So we need to federate these many authoritative sources of truth, or ASOTs. That requires us to carefully manage those ASOTs and share them. And that requires us to establish some sorts of standards to achieve model and data interoperability. We want to transition from our traditional approach that's replete with lengthy, discrete analysis activities into a more continuous assessment and synthesis process. So we look at the landscape of potential assets on all sides, blue, red, and gray, and they're changing almost continuously, as is the environment and the context in which they all operate. So we need to improve our ability, the agility and velocity of our assessments and our analysis to keep pace with that rapid change. We need to be able to find the needles in the haystack of the terabytes of data that we accumulate, and find the robust configurations of these assets that can deal with that rapidly changing environment and context without having to reconfigure themselves all the time. And if we can, we want to be able to perform this assessment in real time so we can reconfigure our assets in the midst of an ongoing operation to account for the evolving order of battle and the evolving environment. So we need to adapt to an increasingly high-dimensional landscape of options. There's huge trade space of configurations to consider, and deep uncertainty in the unfolding of future events and their implications. So there are very different notions of value among this very large and disparate set of stakeholders that are operating and managing the various assets that need to come together to achieve a mission. And we'll become more reliant on probabilistic analysis and visualization to deal with that high dimensionality and manage the trade-offs among the huge trade space of requirements, objectives, missions, systems, and so forth. But yet we still need to collapse that complexity in order for the decision makers to be able to make their decisions. You can't give them a 150 dimensional answer to their problem. You need to be able to collapse that in a way that allows them to understand the trade-offs and make an informed decision. We need to facilitate mission agility by designing our systems to be more agile and making our own workforce more agile, and make these systems of systems easier to compose, not only in the physical space, but also in the analysis space. We need to be able to enable new missions with the assets we have and reconfigure those assets potentially in the heat of battle, and be able to do that with the analytical models and data that we use in order to determine what those configurations ought to be. On the non-technical side, we really need to federate knowledge from these many organizations. And so we need to incentivize collaboration and sharing of that knowledge, information, and data, and then sharing of the systems and services and capabilities that they create. We have traditionally organized programs of record to focus primarily on their individual success, but that comes at a price. We lose sight of the forest by focusing on each tree, and we need to try to influence system acquisitions to think a little beyond their immediate needs to better accommodate partner needs or future needs that we haven't even discovered yet. And we do that by incentivizing the achievement of some of these nebulous non-functional requirements like modularity, interoperability, and so forth when we implement the systems. And we need to foster a culture that really embraces continuous assessment and improvement. Because we need to be able to perform these analyses on a nearly continuous basis to keep pace with the rapid evolution of our enterprises of systems and the context in which they must operate. And with each of these organizations developing their individual authoritative sources of truth, we need to establish governance mechanisms and recognize that no program is an island. So by better understanding the dependencies between these systems and the implications of the decisions we make for the systems that we manage, we can improve the quality of our decision making, not only for our individual programs, but understanding the implications as they roll up to the mission and the enterprise levels. And the challenge is to balance the needs of individual programs with the needs of that broader enterprise and the missions to which that program contributes to, both now and in the future. We need to expand the horizons of the decision space and really open folks' minds up to more broadly address these non-material solutions and non-traditional innovative solutions and a wider range of threats than they're typically accustomed to. Really, balancing the desire for optimization against the immediate known threats and the immediate technologies that are available, and be able to provide flexibility to adapt as those change. and valuing those key non-functional requirements I mentioned that enable us to achieve better system of systems agility, and value those over the optimization of performance in individual system stovepipes. So there are a lot of emerging robust decision-making methods to address that deep uncertainty, but a lot of folks are still used to thinking in very deterministic terms and using a very small number, sometimes one, vetted scenarios with which to base some very substantive acquisition decisions. And to make all this happen, it's really helpful for mission owners to have money to be able to support all this work, rather than expecting individual programs to fund these fundamentally cross-program analyses. So if you go to the next slide, I think this is the last slide. Basically, the key themes I see for mission engineering enabling research are those key technical and non-technical challenges that I articulated on the previous slide. And so these are just the major bullets from that previous slide on the left. On the right, there's some of the methods, tools, and techniques that I think are going to become increasingly important for the practice of mission engineering. So complexity theory, system science, and systems thinking can really help us to understand and deal with the increasing complexity of both the problem space and the solution space. Smart cities is just an example of an area where there might be some substantive new ideas coming out of the defense site community that could be really invigorating and innovative compared to what we're used to thinking about within our sphere. Big data analytics is going to help us to make better sense of the terabytes of data we collect through our analysis enterprises, as well as from the deployed systems. Machine learning and artificial intelligence can help us deal with all that complexity and find the various patterns that may not be as evident to our poor human 7 ± 2 brains. I talked about high dimensionality and approaches for dealing with that high dimensionality in both analysis and visualization, and collapsing the trade space for decision makers is going to become increasingly important. And transdisciplinary approaches will really help us to incorporate some new ways of thinking to address the same problems in fundamentally different ways. Lately I've been increasingly involved in MBSE methods and tools, and they can really help us to capture information about those systems and enterprises and missions, and really help us to manage those increasingly complex enterprises. And so integrating those models and data is going to be foundational, and standards are going to be a key part of achieving that interoperability. So some standardized approaches for constructing those models can really help with the interoperability problem. And the digital twin concept can really help us as we deploy those to better understand the real capabilities of our systems rather than just what they were designed to do. And then we can roll up these individual system level digital twins to provide that same degree of understanding at the mission engineering level and at the enterprise level. We can really help to inform those kinds of analyses, especially those across multiple missions. So I think that's it. Looking forward to your questions. Thank you.
Excellent, Ryan. Thank you very much. And last, Donna Rhodes, we'll turn the program over to you, Donna.
Thank you, Judith. Could I have next slide, please? So I'd like to just give you a snapshot of my personal history that's going to inform my remarks. I'm basically at a point in life where I can divide my journey into three almost equal parts. In the first part of my early education and work was in anthropology, and I became an archaeologist. And then I went back to grad school and got into system science. And in system science, my PhD advisor had developed a model of the mind based on system science, and we worked on cognitive science related things. Consequently, he was also best friends with one of the early pioneers in systems engineering, and that was kind of the seed of where I started working in systems engineering. So subsequently, I went into industry, and I spent a good part of my career there, where I was working primarily on aerospace and defense programs. And I was really engaged in the whole evolution of systems engineering as a profession. That was in IBM Federal Systems, which then, of course, became part of Lockheed Martin. And we developed early, profiles of what is a systems engineer. I was responsible for my organization's systems engineering competency strategy and so forth. So my orientation was around research and people. And then in this last phase of my journey, I am in academia, and when I first arrived there, I think it was still about more traditional systems engineering, though we had certainly gotten into model-based approaches already. But here we started to think about system of systems. I was on a Air Force Scientific Advisory Board panel in 2005 that said, is system of systems engineering really any different? And in that study, I think certainly one of the themes that came through was the importance of thinking about the people. Now, as I kind of move forward in thinking about this next frontier, which I think mission engineering is like this next evolution of this journey on the engineering of systems, I really am very focused on the workforce kind of issues. You know, how do we educate the future workforce? And in doing that, I really kind of need to return back to my roots there in my early days around the idea of this systems model of the mind and cognitive aspects of that. Could I have the next slide, please? So let me orient, although there are many, many challenges that face us in mission engineering that the other panelists have described that are so important. I think that really the future of how successful we are in mission engineering is not only going to depend on evolving our current workforce, but also the education of our future workforce. And we can even move that back into the STEM arena. So we've been doing some work across different universities, I think, that have started to produce some results that are important to this idea of what is this higher order thinking that we need for mission engineering. At MIT, we've had some doctoral students work on the systems thinking from the concept of doing empirical studies and case studies. Heidi Davids did one of the earliest empirical systems thinking studies about the formation of senior systems engineers. And then a few years later, Caroline Lamb did a look at collaborative systems thinking. And what she found in that empirical work was that teams are capable of systems thinking that is somewhat different than the individuals. It augments that. I think we all know this, but it's important to say that we have this research behind it. I think what's going on with capstone project, that's a critical enabler for how we develop the workforce. And there's a recent paper that came out of NPS that's excellent on describing capstones for mission engineering, if you haven't seen that one. The SERC has done some fundamental work in this area, starting back with Nicole Hutchinson's work, especially around systems mindset and thinking. It isn't one thing, there are these multiple dimensions to it. And that work has been further developed in the recent work on mission engineering competencies. So that's also an excellent piece that contributes to this idea of how do we create our current and future workforce. And then another interesting thing that I've been reflecting on again lately is work we did at MIT on interactive games. And in this sense, we were trying to educate students to not only be able to make systems type of decisions, but to make that under uncertainty and under changing context, policy changes, resource changes, all mission changes. And an interesting aspect of that popped out was that we found that our students always played themselves. And for example, there were students who were always exhibiting risk-taking behavior. And there were other students that were very risk averse. And there were so people kind of got locked into that. And so the game was evolved to include personas so that the players would have to kind of put themselves in the shoes of a different person who had certain types of propensities and behaviors and roles. And I think that is an important part of when we think about educating workforce, is this idea of getting people to not get anchored in their own thinking, but to step out. So those are some of the things I think that we've learned and that we continue to develop. And if you go to the next slide, what I think is part of this is that we've thought about what kinds of capabilities our systems thinkers need. We started taking that down to a next level. But I don't think we've really gotten at this fundamental idea of intelligences that are involved. One of the piece of work over the years in the psychology and education field is around multiple intelligences. Howard Gardner, for example, developed the theory of multiple intelligences that really said that we have to expand our view and we have to think about educating from this perspective of multiple intelligences. And this was the idea that intelligence isn't just a single construct, but these distinct different intelligences that interact in a meaningful way. So this has had me thinking about, well, what are these intelligences? And I don't have an answer for you today, but some of the preliminary thoughts that I have, I'll focus on 4 things that I think may be important from my perspective. One is the kind of intelligence it takes to do ecosystems thinking, and that involves thinking about a value perspective and creating value strategies. And I think that with mission engineering, we find, for example, that we have stakeholder saliency changing. Who has power and authority and legitimacy in decisions? And entering into that, for example, is gray zone. If we're starting to think about different kinds of actors in mission engineering ecosystem, how do we get people to think about that and to take all this complexity? How do we think about externalities? A second area is around adaptive capacity. And that intelligence is multifaceted. And I think it's an individual, but also kind of a social capacity that we have at a team level. And one of the things that I see is that's important is the ability to kind of move across these different opportunity strategies that we use. I see a distinct difference in recent years in graduate students who are invoking now platform thinking. And I'm not talking about DoD military platforms, but business strategy platform thinking. There was a recent article in Wired magazine that explains this, I think, quite well. And says, if we have a certain mission or problem that we want to address, that there are 3 kinds of perspectives or strategies one could take. One is the stuff perspective. Let's build the stuff. Let's make more stuff. The second is optimization. Okay, we have all this stuff and we have all this data science stuff now. How do we kind of optimize where we put our stuff and how to move it around? I think that might be where we are as a field now. And then there's the true platform thinking, which is how do I create something that will end up where I don't have to create all the value myself? How do I get others to participate and create value for my platform? So it's that kind of thinking we need to get out of our usual anchored thinking in different strategies that we have and say, what else could we do? The third area, anticipatory thinking, I think is so important. Something I've been thinking about throughout the whole journey of my career. And anticipatory thinking is important because we as humans are inherently anticipatory. And what that is that we have these internalized models in our head that we can draw on. And for those of you who are are watching the Queen's Gambit, this is think of this as Beth Harmon with her chessboard on the ceiling, working through these chess strategies. So we can work with these models. I've certainly observed that some people are better at this than others. And so I think that we have a tremendous opportunity to use augmented intelligence to help us with doing anticipatory thinking, but we still need to educate our workforce to have a strong capability for this. And then the fourth one I'd mention right now is harmonizing and synchronizing. Harmonizing in terms of bringing things into agreement, and synchronizing as, if you will, controlled movement in time. This is, I think, somewhat analogous to what Howard Gardner called musical intelligence. And many of you, of course, know the story where companies like IBM, before they were educated computer programmers, hired people with musical backgrounds to do that work. So there's something inherent about that, something fundamental. Gardner had this quote around musical intelligence where he said, all composers begin as performers. And so this begs the question, if we want a workforce that's capable of doing this activity within mission engineering, how do we give them this experiential learning that will allow them to practice as performers so that they eventually can be the composers? So that is a summary of some initial thoughts around this, but the basic thing is that our future of mission engineering, which I think will continue to get increasingly complex and sophisticated, demands that we not only think about changing our current workforce, but educating our future workforce. So thank you. I'll turn it back to you, Judith.
Great. Thank you, Donna. And I'll now turn this over to Dan for the question and answers.
Thank you, Judith. Thank you, everyone. Great panel, great thoughts, and as always, Don is a great cleanup hitter. I think we have a little bit less than 10 minutes for questions, so let's dig right in and ask our panelists to keep your responses short but pithy, entertaining, and etc. Dr. Verma posted a question for Elmer in the Q&A. Really loving, as I did, this notion of reversing the value stream to focus a paradigm that focuses more on missions, identifying where the gaps are. Question is, of course, what are the challenges to doing that, and are they less technical and more organizational and cultural? Elmer?
Yes, no, thanks for the question. Yeah, as you start thinking with the, start with the end in mind, right? That's the challenge. I mean, as we have heard from the other panelists, it's how do you teach new tricks on old dog, right? So we got to unlearn a lot of things, and look at things from the perspective of if I need to accomplish an objective within a particular mission, instead of going in and trying to identifying a platform first and then identify a mission for it. We want to look at that from the other end. It's just that if I've been tasked to do a particular operation, and then we know that if we're going to be in a contested environment, in the case of the Department of Defense, we would to be able to explore all the options first, and then from there backtrack in terms of what are the capabilities that we need. So it's a little bit of a challenge. However, a lot of these activities are already taking place within the department, within industry, and a lot of the practitioners that support the department. The issue is right now is to figure out how do we converge all these ideas and all these concepts into some sort of framework that it becomes more of a discipline that people can follow and we can articulate kind of in a similar fashion. So that's what we're trying to head right now with the mission engineering guide and a lot of the perhaps things that Sandy mentioned in her talk with regard to how do we converge, like I said, in terms of the process that we would like to follow, and very important is really to truly understand. Do we truly understand what are we asking? What's the research question? What's the problem statement? And start with that. For the most part, in the department, when you hear the questions will be along the lines of, where are our capability gaps for a particular mission, without truly understanding what the mission is and what are we trying to achieve with regard to the mission itself. So that's the key starting point of all of this.
Thank you, Elmer. Any quick comments from others before we go on to the next topic? All right, I'd like to navigate to a question I wrote down that I think is the elephant in the room, given all the perspectives of the panelists. In one way or another, all the panelists mentioned the people problems, starting with Elmer, moving down. And probably problem is not the right term. It's the challenge of making sure folks who are doing the mission engineering of today and thinking about what the next generation challenge and refocus should be. So, and I also enjoyed Dorothy, some of the words Dorothy used in terms of, let's see, quirky and non-traditional. Sounds like the start of a job search ad for a faculty member. So Dorothy, let me start with you, and given your long experience, where do we start in terms of the workforce retraining, if that's the right term for today's workforce, and what are some of the really important things academics should be doing to look carefully at their syllabus for training the next generation?
So I'd like to underline the point that Donna made about games, because we humans have a much easier time learning than unlearning. And the most effective way that I've seen for humans to unlearn is participating in games. You get a lot of real-time feedback, you iterate, and the educational establishment has flirted with the idea of games on and off over at least the last, 50, 60 years, something like that. But it's never really hit the mainstream. And I think maybe it's time that it does that. And I suggest Donna might have some other good observations on this.
Yeah, I definitely agree with you, Dorothy. And one of the things that I've observed over the years that I've seen people working on game-based education is that there tends to be focus on undergraduates and thinking that, when we grow up, we don't need these games anymore. But it's just really quite amazing, I think, when you get some people who are graduate students or professionals playing these more serious games, and what kinds of learning and insights can be made individually as well as, I think, shared, especially if you have a discussion afterwards about what happened. So lots of fun potential. I've seen, probably like you have, Dorothy, like peaks and valleys of people popping up and doing game-based work. I think there's, in fact, I think there's currently some work at Lincoln Labs that's going on that looks promising, and there's pockets of this in different places, but we need to bring that forward.
I would actually add, I'm actually performing on a DARPA program right now called Game Breakers, that's using the notion of people playing real-time strategy games and trying to build models to understand where the balance is in those games. But the program manager himself has said, one of the challenges that he's going to face is taking this work and convincing other people who could use it that it's meaningful, because, don't dismiss it because it's based on games. And so that challenge will probably persist. Any other comments on the huge topic of the people and how we develop and enhance the skills of our current folks? All right.
Well, Dan, I would only say that in terms of the future, it also requires re-educating the educators, right? So it's kind of an open-ended problem because we're talking about changing like the 4 types of thinking that Donna was mentioning. I think the current education system limits them, right? Disables them, basically. And if we would talk to most of our colleagues, would they see the need for this type of learning, right? That's a question mark. So I think it's not only the workforce, but for the future, there is institutional change also within education to enable the education of the future generations, I believe.
Well, I agree with you, and I'm going to make you blush. Your career and your role in academia is just so exciting to me because of those perspectives you bring, and so keep it up. I know you've had to climb over a million walls, but and there's more out there, but we'll do it together. All right, now the fun question with the few minutes we have left. I used this on the panel I chaired at the SSRR last year. And I'll open it up to whoever wants to jump in. So here's the time when we give you a magic wand and a magic wallet that's very stuffed. What would be our research challenge that you would come to the SERC with in the mission engineering area? What would it be, and why do you think it's important? Maybe start with Ryan.
Yeah, I think one of the biggest areas that could use that infusion is dealing with high dimensionality, high uncertainty, and you know, being able to conduct that analysis, be able to make sense of all the data, and visualize and collapse it in a way that could be evocative enough for to inform decision makers. I think that's kind of the key area that I would see.
And Ryan, if you would tag onto that, having some of the output usable in immersive modeling type games, I think that could be immensely powerful.
Absolutely.
Yeah, I think I would go with aggregation of goals. I think that's one that I've seen extremely difficult across, like deep and broad. I don't think we know how to aggregate goals meaningfully.
Very good. Elmer, you may not have a magic wand, but you may have a magic wallet. Would you like to comment?
Yeah, I think our biggest challenge again is the synchronization of all these efforts, and so having a digital ecosystem that helps us integrate all the tools and resources that are out there, and in particular when they get down to the models themselves, it's how do we analyze the effects of combined systems. In this case, the aggregation of different capabilities and their effects on a mission. So we don't have a capability really in the department right now to do that sort of thing, that level of analysis, whether either you use an EW or cyber or any other kind of capabilities to accomplish a mission. How is that is evaluated and analyzed? Right now it's all individual, still 5 models, and we have to figure out how do we integrate them. So we got a lot of work to do. I mean, I think we're in the first grade towards getting a PhD in mission engineering. So we're looking forward to this journey as we go on.
So I would use my magic wand to focus on not making us our own worst enemies as we take the power of data science and visual analytics and models and create augmented intelligence that can help ourselves and end up creating things that are totally not at the speed of human thought, or that are so complex that they're actually counterproductive. So I think tremendous opportunities there, but it can also be a huge danger.
Excellent. Any other thoughts? If not, there is one question popped into the Q&A that we'll have to answer briefly. If I could focus this to Donna. Very, very nice question. You spoke, Donna, about the multiple intelligences, but of course, maybe one person would never excel in all of those categories. So does it basically become a composition of a team that has complementary intelligences as the key challenge?
Yeah, and I think that the area of multiple intelligences is that we all have all of these intelligences, and we definitely, I think, have, in my view, like preferences or strengths that we have. And some people would argue they're inherent, and some would view that we can train those in. Like there's a line of thought around structure of intellect that I was trying to apply in industry, where you can actually train people to do this. But the bottom line is, yes, if we can create teams where we can actually understand who has these certain strengths and propensities, how can we build that so that we can draw on those and bring forward the best of us in making team decisions? lots of work. I'm not the expert on all this stuff, but I think that, you know, there's a tremendous opportunity for us to tap into some of the wisdom that's been developed.
Great, thank you. Well, and a broad thank you to all our panelists. I think our time is up, but fabulous coverage of the need, but also the opportunities and what we can do together to advance mission engineering as a capability. And again, dovetailing wonderfully with Dr. Magnus's talk. So Judith, great partnering with you on this panel, which has been long in the planning, as you know. And so I want to thank everyone. And we have only a few minutes left before the session starts. So look forward to interacting with you in the rest of this wonderful event today. Thank you.
Thanks, everyone.
Thank you.
Thank you, everyone.
Thank you.